Hello, this video is on energy carriers in the cells and in various metabolic processes involving cells. So basically, how does this energy get processed? It's largely by way of redox reactions, oxidation reduction reactions. And you may remember from Marion High School, oil rig. Um, Oxidation is loss, reduction is gain. Of course, I learned ox loss. When something is oxidized, it loses electrons. And so that's like, here, let me give you my electrons. It's giving energy to something else. And so if something is reduced, RIG rig, it's reduced its gain. So the thing being oxidized gives up electrons, the thing reduced gets electrons. You know this. So meet NAD, my next door neighbor. NAD is an energy carrier. Don't get too close to him. But anyway, he's a B student and he's addicted to nicotine. Well, that is to say that NAD, which stands for nicotinamide adenine dinucleotide, surely you don't have to remember that. But you can see nicotine at the front. Dinucleotide, it's got some nucleotides, not nucleotides, but anyway. So this NAD, NAD, comes from vitamin B3, which is niacin. How do you get niacin? Well, I looked it up. There's niacin in avocado. It's also in fish and poultry and meat. So, but everybody eats that stuff, right? Unless you're not, unless you're a vegan or something. But anyway, so you like avocado, right? So vitamin B3, avocado will get you. He's a B student. Get it, B student. Um, that's where the NAD comes from. Okay, so NAD is an energy carrier, um, which means that it can be oxidized and it can be reduced. And when it is oxidized, it loses electrons, ox loss, and thus donates. And when it donates an electron, it loses some negativity, right? Because electrons are negative, and it becomes NAD positive. So NAD gets a plus when he's oily. NAD plus. NAD gets a plus when he's oily. So when NAD, nicotinamide adenine dinucleotide, when it's oxidized, oil, ox is loss, O is loss, it becomes positive because it's lost some negativity. It's become positive. So that when it's oxidized, it gives up an electron. When it adds an H, that's when it gets reduced. Because then it has gained an electron and a proton for that matter, because a hydrogen is one proton and one electron. So NAD gets reduced if he raises hell, where hell begins with the letter H. Okay, so NAD adds an H when he's reduced. Okay, so this is the oxidized form. This is the reduced form. Of course, ATP is the big energy carrier. This is money in the bank, adenosine triphosphate, now showing at a cell near you. And so this is, it's like a money bank, like a rechargeable battery. Here, take my phosphate. And so the money is the phosphate. If it gives you a phosphate, it's giving you the money. So when you break off a phosphate, and there's an old commercial, give me a break, break me off a piece of that phosphate bar. It was Kit Kat bar, but anyway. So when it breaks off a phosphate, which is the cat, remember, it breaks and it gives off electricity. This is called dephosphorylation. D means not or from, and so when it's dephosphorized, it's lost a phosphate. So dephosphorylation is the loss of a phosphate, and that's releasing energy. Okay, so it gives off energy when it gives off a phosphate. So this is the adenosine triphosphate. So this is adenosine on this right side here. And so if it's triphosphate, then it's got 3 phosphates, alpha, beta, gamma. If it's so that's now if it's adenosine monophosphate, then it wouldn't have these 2 here. It would just have a monophosphate. So adenosine monophosphate. If it's adenosine diphosphate, then it has 2 phosphate groups, not this one, but this would be adenosine diphosphate, and then the whole thing is adenosine triphosphate. And so when it breaks off the gamma, it's given off, I'm giving out money, it's giving out phosphates. And that gives off energy. So some terms. So hydrolysis is what you use to break apart the phosphate. Now the water also breaks apart into a hydrogen and a hydroxyl, group. But hydrolysis is what breaks apart the phosphate. And the process of adding. So if dephosphorylation is taking off a phosphate, then phosphorylation is adding a phosphate. Okay, phosphorylation adds a phosphate to, say, adenosine diphosphate. And when you add a phosphate to adenosine diphosphate, what do you get? You get adenosine triphosphate. Okay, so this process of creating ATP mostly takes place in the mitochondria. The mitochondria is where this phosphorylation takes place. 90% of the creation of ATP by phosphorylation, of adding phosphates, takes place in the mitochondria. Now, this process is something I didn't feel like the book really explained what it was, but so I'll end by just mentioning it. Chemiosmosis. This is the way that phosphorylation takes place in the mitochondria. It's called oxidative phosphorylation because it involves oxygen. But the book wasn't at all, at this point at least, clear. Maybe the rest of the chapter is clear. But the first section of, and by the way, I'm following Clark, Choi, and Douglas's Biology 2E here. The first section of this chapter didn't seem to give much of a sense of what that even meant. So, energy carriers. In this video, we've talked about 2 energy carriers: NAD, my neighbor, NAD, and also ATP. And so the energy carrying takes place mostly by way of redox, oxidation reduction reactions. The oxidized form of NAD is oily, NAD plus. And then when he's reduced, he adds an H. Okay, NAD. ATP, adenosine triphosphate. It's like when it breaks off in dephosphorylation, then it releases energy. Again, that's 1 phosphate, 2 phosphates, 3 phosphates, and the process of breaking it apart is hydrolysis. And then phosphorylation is when you add the phosphates back on. 90% of that takes place in mitochondria. This has been a video on energy carriers.